Hey everyone, Mr. Hauk here. In today's video, we're going to be looking at a collection of problems to help prepare us for our Unit 1B test. Let's go ahead and get started. Problem 1 here says, which function has an amplitude of 3 and a period of pi over 2? Well, we know that the amplitude represents the a term. The absolute value of the a term is going to be the amplitude. So let's look at the a terms here. Answer choice A has an a term of 4. So this would be wrong. This has the wrong a term. Answer choice B has an a term of 1/2. This would be incorrect. C and D both have amplitudes of 3. Okay, so we've got the amplitude of 3. Now we need to figure out which problem has a period of pi over 2. Well, since these are both cosine problems, we know that the cosine, or the period of a cosine, is t the period equals 2 pi divided by b. Well, we know we want the period to be pi over 2. So we're going to say that pi over 2 equals 2 pi over b. Well, let's go ahead and do some cross multiplying. Anytime you have a fraction equal to another fraction, we can cross multiply. So pi times b, that's pi b. 2 times 2 pi equals 4 pi. Let's go ahead and divide both sides by pi. And we get that b equals 4, because we can see the pi's here cancel out. So the correct answer choice would be D, because we have the amplitude of 3 right here, and we have the b term of 4. All right, number 2. What is the equation of the graph below? Graph is from 0 to 2 pi. That's going to be some very important information for us. This graph is going from 0 right here to 2 pi, which is right there. So couple things to notice about your answer problems is that they all have a terms of 3, so that's not going to help us too much. What we need to look at is the b term, which helps determine the period. So we can see that since the graph is from 0 to 2 pi, 0 to 2 pi, let's count how many cycles that we see. First off, notice that it's starting at the origin, so I think, starts at origin, which means I'm going to look at a sine function. So if I'm thinking about the problem starting right here, let's count the number of cycles that we can see. 1 cycle, 2 cycles, 3 cycles, 4 cycles. There are 4 complete cycles from 0 to 2 pi. Remember that the parent function of sine has 1 cycle, goes through 1 complete cycle from 0 to 2 pi. So this means that our b term is going to be 4. Well, we have a 4 here, and we have a 4 here. But remember, we said that because this is going through the origin, that this is going to be a sine function. So I'm going to go ahead and cross out these cosine functions, and from the answer choices remaining, the only one that has a b term of 4 is going to be A. So that's going to be our answer choice. Now, let's go in and check to see if this is correct using Desmos. So we have 3 sine of 4x. Notice that here in Desmos, I've already set my step to be pi over 4. That way I have my x-axis going in terms of pi over 4. And we can see the amplitude of 3. And we can also see by the time we get to 2 pi that we go through 4 complete cycles. So 3 sine of 4x is the correct answer choice. Again, some of the other key features we see also are going through the origin because it's a sine function. So this is indeed the correct answer choice. All right. Problem 3. Solve 8 sine of x plus 4 equals 0. First thing we want to do, since we're trying to solve for x, is do everything we can to isolate x. So I'm going to start by subtracting the 4 to the other side. This is going to give us 8 sine of x equals negative 4. Then we can divide both sides by 8. This would give us sine of x equals negative 4 over 8, which means sine of x equals negative 1/2. And what we're looking for is x is going to be, x is an angle, x is between 0 and 2 pi. X will be the angle that is the inverse sine of negative 1/2. So that means we're looking for all angles between 0 and 2 pi that have a sine value of negative 1/2. Well, if we jump over to our unit circle, and remember that the sine value is the y value, we have a sine value of negative 1/2 here at 7 pi over 6, and we have a sine value of negative 1/2 here at 11 pi over 6. So our answers are 7 pi over 6 and 11 pi over 6, which is answer choice C. Now, there is a way to check this in the calculator with Desmos. What you have to do is you have to make sure that your equation is set equal to 0. Well, notice that this equation is already set to 0, so if I take 8 sine of x plus 4, and I plug that into Desmos, it's right here, 8 sine of x plus 4, we can look for all the places that this function crosses through the x-axis, because remember, a solution, when an equation is set to 0, will be the x-intercepts. So between 0 and 2 pi, we have a solution at 7 pi over 6, and we have a solution at 11 pi over 6. Again, we had to make sure that that equation was already set equal to 0 before putting it into Desmos. All right, next, looking at problem number 4. 1 equals 2 sine of theta minus sine squared of theta. Now, I'm going to go through and handle this graphically. There's a couple ways you can do this. I'll show you also another method that we can use, but let's handle this graphically first. So once again, if I want to use Desmos, I'm going to need to go ahead and set one side equal to 0. And I usually like the squared term to be positive. So I'm going to add sine squared to the other side, and I'm going to subtract 2 sine theta to the other side as well. And that's going to give me sine squared of theta minus 2 sine theta plus 1 equals 0. Once I have that, then I can go ahead and plug this into Desmos or a graphing calculator and look for all the locations that this curve will cross through the x-axis. So let's see what that looks like here. Well, it doesn't look like we're going to cross through the x-axis, but we are still making contact with the x-axis, and that would still represent a solution. And we are making contact with the x-axis at pi over 2. Okay, so our answer here would end up being pi over 2, which is D. Now, let me show you how you could get that without the calculator. So when I look at this, I can almost think of the signs as x's. This would almost be like x squared minus 2x plus 1 equals 0. And if you think about factoring that, that would factor as x minus 1 times x minus 1 equals 0. But now let's replace the x's with signs. So this would be like, this would factor as sine of theta minus 1 times sine of theta minus 1 equals 0. Then by the zero product property, since we have two things being multiplied together equal to 0, that means we can set these factors equal to 0 and solve. Well, they're both the same factor. They're both sine of theta minus 1. So if I take sine of theta minus 1 and set it equal to 0, then we would get sine of theta equals 1, which means that theta is the inverse sine of 1. And what this means is we are looking for an angle theta where the sine value is a positive 1. Well, if we look on our unit circle at pi over 2, we have a sine value or a y value of positive 1. So theta is equal to pi over 2, which just confirms exactly what we saw when we graphed it and found the location where the curve touches the x-axis. All right, number 5, what is the period of the given equation? Well, we have y equals 5 cosine of 1/3 x. Remember that period for a sine or a cosine function, period is equal to 2 pi divided by b. This is for sine or cosine. And we can see that the b term is 1/3. The b term is always the, no, go back. Where did that go? There we are. The b term is always going to be x's coefficient, or whatever the variable is, the coefficient of that variable. So let's go in here. T equals 2 pi divided by 1/3. Well, we're dividing by a fraction, so this would be 2 pi times the reciprocal 3 over 1, which is 6 pi over 1, which is just 6 pi. So the answer here would be B, 6 pi. All right, moving on to our next problem. We want to solve cosine squared plus 5 equals 6. Once again, I'm going to take a graphing approach first, and when graphing, we want to make sure that one side of the equation is equal to 0. So I'm going to take this 6, subtract it over here. So that would give me cosine squared of theta minus 1 equals 0. Let's go ahead and check this graphically. So cosine squared of x minus 1 equals 0. We set it equal to 0. So we're looking between 0 and 2 pi. I can see there's a solution at 0. I can see there's a solution at pi. Now there's also a solution at 2 pi, but we'll come back to that here in a second. So notice that our interval 0 to 2 pi is not less than or equal to 2 pi, which means that we're looking between 0 and 2 pi, but not including 2 pi. So between 0 and 2 pi, the only two solutions that we saw were 0 and pi. So D would be our correct answer choice here. Now let's also go ahead and solve that without a graphing calculator. We want to try to isolate for theta, so let's add 1 to both sides. This would give us cosine squared of theta equals 1. We know we need to take the square root of both sides. So cosine of theta equals, don't forget the plus or minus, one of the big mistakes I've seen in the past. Cosine of theta equals plus or minus 1. And that means that theta is equal to the inverse cosine of plus or minus 1. So what we're looking for is all locations between 0 and 2 pi that the cosine is either positive 1 or negative 1. And we can see on the unit circle, at 0, the cosine is positive 1. At pi, the cosine is negative 1. And then getting back to 2 pi, the cosine is positive 1 again. But remember, we're not including 2 pi in our interval. So the answer choice there, 0 to pi, or 0 and pi rather. All right, problem 7. Find the graph of y equals negative 3 cosine of x. Well, a couple things that we can notice here. First, the amplitude, if we took the absolute value of negative 3, the amplitude should be 3. And we can go ahead and eliminate answer choice C, because the amplitude here is 1 from the midline to a maximum, or the midline to a minimum. The distance is only 1, so we get rid of answer choice C right off the bat. Next thing we need to take a look at is the fact that this is a cosine function, and this cosine function has not been shifted left, right, up, or down. There's no phase shift, there's no horizontal shift, meaning that if you look at A and B, both A and B pass through the origin. Well, we know that cosine does not pass through the origin unless it's been shifted. Sine does. So we know that both A and B, because of where the graph is passing through, we know those could not be correct answer choices either. So by process of elimination, we actually have answer choice D. And we can also see in answer choice D, we know that cosine has a maximum on the y-axis, but because of this negative, it's been reflected across the y-axis, or sorry, the x-axis. So if you think about this point up here being reflected across the x-axis, we get to that point down there, and that does make a lot of sense. Now let's verify this graphically. Let's go ahead and graph y equals negative 3 cosine of x. All right, here we are, y equals negative 3 cosine of x. We can see the 0, negative 3 down here, some other points of interest. We can see pi, comma 3, 2 pi, comma negative 3, and just verifying with our graph, we can see some of these same points here. 0, negative 3, pi is right here, pi would be up here at positive 3, so we can see those points and everything checks out. Problem number 8, determine a possible equation of the following sine graph. Important that we recognize that it's a sine graph. So we know that sine passes through the origin, and origin being right here, notice that if we simply shifted whatever point was at the origin up to, this is where it would fall, and then we can see the shape of the sine curve right there. So it looks like the only thing that has happened is a vertical shift up 2. Let's figure out which of these functions has a vertical shift up 2. Well, this has an amplitude change of 2. This has a phase shift because it's 2 being added to x in the parentheses, so this is a phase shift of left 2. This would be a vertical shift of up 2 because we are adding 2 outside of the parentheses, so we're adding 2 to the entire sine piece. So the correct answer choice would be D. Now, once again, common theme here, let's double check our answer in Desmos. So we want to graph sine of x plus 2. Here's sine of x plus 2, and we can see some of the points that we're looking for here. I see 0, 2. I see pi over 2, 3. Let's see if we can see those common points as well. Here's 0, 2. Here's pi over 2, 3. We see some of those common points, and everything looks like it's checking out. All right, now let's take a look at problem number 9. This time, we want to determine a possible equation of the following cosine graph. Okay, so let's think about this here. We know cosine has a maximum on the y-axis. We can see a maximum here on the y-axis, so we know there has not been any kind of phase shift left or right. So I'm going to go ahead and get rid of, oh, none of them have phase shifts. That's good. Okay, let's think about the amplitude real quick. We can see the midline is right here through 2. So let's go ahead and actually draw in the midline in a different color. So there's our midline, and the distance from the midline to any of the maximums or to any of the minimums is a distance of 1. So we know our amplitude is going to be a positive 1. I'm going to take note of that here. Amplitude equals 1, which allows me to automatically get rid of A and B because they both have amplitudes of 2. Okay. The other thing that we can take note of, we see that since the midline has been shifted up 2, we know we have a vertical shift of plus 2. That doesn't help us too much because both C and D have vertical shifts of plus 2. So what we really need to look at is the B term. That's the only difference in answer choices C and D is the B term. Okay, so well, let's figure this out here. We know that for cosine, sine and cosine, that the period is what's affected by what the B term affects. And we know the period is 2 pi divided by B. Well, let's look at the period on this graph. Remember, the period represents the horizontal length of one full cycle. So if I start here and I trace this cosine curve, this has a period of 3. Okay, t equals 3, period of 3. So I'm going to replace t with 3. 3 equals 2 pi divided by b. We're trying to figure out what b is, so let's multiply b on both sides. That's going to give us 3b equals 2 pi. Divide 3 on both sides, so we get b equals 2 pi over 3, which means that the answer choice has to be D. Okay, so the answer number 9 is D once again. Let's go ahead and double check in Desmos here. So we have cosine of 2 pi over 3 x plus 2. Looking for some common points that they might share. We can see 0, 3. We can see pi over 2, or sorry, not pi over 2, 1, but 1.5, 1. We can see 3, 3. And if we look over here, we can see those same points. 0, 3, 1.5 or 1.5, 1. We can see 0, 3 right there. So this is indeed the correct answer choice. All right, number 10, determine a possible equation of the following tangent graph. So let's think about a couple things here. Number 1, if we look at our answer choices, the only change in any of them, the only difference between any of them is the b terms. Okay, all the b terms are different. They have no other features. They don't have any vertical shifts, no horizontal shifts, no a term changes. Remember, tangent doesn't have an amplitude, but it still does have an a term that represents kind of the vertical stretching. So we only really need to look at the period. Well, let's think about what the period would look like here. I'm going to draw on some asymptotes. I can see an asymptote here at negative pi. I can see an asymptote at positive pi, an asymptote at 3 pi, and so on. And remember that the period of the tangent function is going to be basically the distance from asymptote to asymptote. So if I look at the distance between negative pi and positive pi, that's a distance or a period of 2 pi. We can see the same thing here from pi to 3 pi. the distance is 2 pi. So remember that for tangent is different from sine and cosine. The period is not 2 pi over b, but rather the period is pi over b. So we can see that for tangent, the period is pi over b, and we already know that, again, the distance from asymptote to asymptote is 2 pi, so we know the period is 2 pi. So I'm going to replace t with 2 pi. 2 pi equals pi over b. And let's go ahead and solve. So multiply b on both sides of the equation. I get 2 pi times b equals pi. Solve for b, we can divide both sides by 2 pi. So b equals pi divided by 2 pi. The pi's would cancel, leaving a 1 on top and the 2 on the bottom. So b equals 1/2. So the only answer choice with a b term of 1/2 is answer choice C. Now again, let's go ahead and verify with Desmos real quick. So tangent of x over 2, remember that x over 2 has a coefficient of 1/2. And looking for some common points, we see 0, 0. We can see pi over 2, comma 1 right here, even though there's not a point at it. There's one right there. We can also see 2 pi, comma 1. And let's see if we can identify those common points here. There's 0, 0. There's pi over 2, 1. Here's 2 pi, 1. Our points are checking out. We're good to go. Problem number 11. Determine a possible equation of the following cosecant graph. Well, a couple things that we know about cosecant. Number one, cosecant is the reciprocal of sine. And we know that sine, the parent function, passes through the origin. And we can see that, this little dotted part, that's the sine curve that we're using to see where the cosecant curve is going to be. So it is looking like this is passing through the origin, but this is actually a little bit deceptive, because when you think about the sine graph, and this is something I want to show with Desmos also. When you think about the sine graph, let's type in the parent function, sine of x. Notice that when the sine graph passes through 0, 0, then it starts to increase up to pi over 2, 1, then it decreases and so on. But if you look at this one here, when this sine curve passes through 0, 0, it's decreasing. So this sine curve has actually been shifted horizontally. It's undergone a phase shift. So notice if I look at this part right here, well, this part starts to ascend and then descend. So if I took this point, notice that from 0, 0, if I shifted to the right by pi, I would be here, and then we can see our typical sine curve. So it's looking like this cosecant graph has been shifted to the right by pi. So phase shift, right by pi. And that's going to allow me to eliminate A and C, because neither of those have been shifted to the right by pi. If you look at both B and D, though, this is a phase shift right by pi. This is a phase shift right by pi. So those are our other two answer choices that we're considering. However, now notice that, oh, go away. Now notice that our midline is still here at the x-axis. And D is saying that we have a vertical shift of up 2. Well, a vertical shift moves the midline as well, and our midline hasn't changed. So D could not be a correct choice either. The correct answer choice has to be B. And let's go ahead and double check that in Desmos real quick. So let's get rid of our sine curve, check 2 cosecant of x minus pi. And a couple points that we want to pick out here. I can see negative pi over 2, 2, pi over 2, negative 2, 3 pi over 2, 2, and let's just check those points here. Negative pi over 2, 2, pi over 2, negative 2, 3 pi over 2, 2. Everything looks good, and it checks out. Now, moving on to our next problem, which best describes the type of graph shown here? Well, we can see these little U-shaped curves with asymptotes. We know we only get those in secant or cosecant graphs, so this would be C, secant or cosecant. Question 13, which best describes the type of graph shown? Well, the only time you're going to get this shape, where we have parts of the graph going infinitely in the x and y, in the y direction, is with tangent and cotangent. So this is going to be answer choice B, tangent or cotangent. And then number 14, our last problem on this little review. Well, we know that we only get this wave-like pattern here with sine and cosine curves. So this would be answer choice A.